in Coach Moore's class, we learned all about gravitational potential energy. This is my reference point, and I like riding my bike, so I'm gonna ride my bike. Safety first. Here, I lost some gravitational potential energy due to the law of conservation of energy. While I was going down the hill, some of my gravitational potential energy transferred into kinetic energy and heat. And now, I'm going to go back up the hill. I went up the hill using kinetic energy. My gravitational potential energy is back at where it used to be. Since I am back at my reference point, my total displacement is 0.
Okay, so now we're going to derive the equation for gravitational potential energy. So as you can see here, we have the equation for gravitational potential energy, which is delta U with G underneath, subscript, is equal to mass times little g times the change in y, okay? So first we're going to start off with our good old work equation, which is Fd, but since it's the force of gravity, it's F subscript g. So basically we want to find the two components of this. So we're going to go here to Fg, right, which is equal to mg, and d, which is equal to the change in y, because it's only moving in one axis here, okay? And so now we have W equals mg delta y. Now, W in this case is equal to the change in internal energy, with internal gravitational energy, right? I meant potential gravitational energy, not internal. And so then we finally get our equation at the bottom here. It's the same as the one before. Okay, so now we're going to move over here to the other side of the whiteboard. Okay, disregard all of this. So, first off, we have gravitational potential energy. Now you're probably wondering what's so important about this, okay? And you know, we had our demonstration earlier with our test subject riding the bike. And so basically, he started off at the top of a hill, right? And as he went down, that energy changed into kinetic energy until he reached the bottom, right? And then it might have been lost as heat energy or something else. It doesn't really matter. But all of the energy was conserved within the system, and that's what matters. And so once he's at the bottom, he decides he wants to go back up the hill, okay? And once he goes back up the hill, he's turning this kinetic energy back into potential energy, or the gravitational potential energy, because he's going up, okay? And going back to where he started. Now, this all depends on the frame of reference, okay? And so the frame of reference in this instance, we put at the top of the hill because that's where he started. So if we have an axis here, he started here and then he went down underneath and then came back up once he came up the hill, right back to the starting point. And so, yeah, that's gravitational potential energy. Yeah, there's not much else to say about this, but it's pretty cool. They use it in roller coasters and, well, loops, things like that. Yeah.
Here's another example of gravitational potential energy. It lost gravitational potential energy and converted it into kinetic energy. Here on the ground, the kinetic energy was transferred into all the other kinds of energy due to the law of conservation of energy.